now we are going to discuss how to determine the composition of fuzzy relations. Now, supposing that, so I have got two fuzzy relations in the matrix form. For example, A is nothing but say A I j and B is nothing but say B j k. Now, how to find out the composition of these two fuzzy relations? Now, the composition that is denoted by C is nothing but A composition B, and this particular symbol indicates actually the composition. So, C is nothing but A composition B. Now, in the matrix form, this can be written as, say I know A I j, I know B j k. So, A I j composition, so B j k is nothing but is your C I k. And how to find out this particular C I k? Now, C I k is determined between the maximum of the minimum of this A I j comma B j k. Now, let us see with the help of one numerical example. So, how to find out? So, this particular C or the composition of two fuzzy relations. So, I am just going to take one numerical example. Now, supposing that I have got one fuzzy relation, that is A is A I j in the matrix form, and this is nothing but say in the 2 cross 2 matrix like 0.2, 0.3, 0.5, 0.7. The next is your the B is another fuzzy relation and in the matrix form. So, this is nothing but B j k, and supposing that I have got a 2 cross 3 matrix and the elements are 0.3, 0.6, 0.7, 0.1, 0.8, 0.6. Now, our aim is to find out the elements of this particular C I k. Now, let us see how to find out the elements, that is your the C I k. Now, here if I just try to find out the element wise, now the first thing is your C 11, that is the first row, the first column element. Now, if you remember, so this particular the relationship, that is C I k is nothing but A I j composition, that is your B j k. Now, here actually what you will have to do is, so here to determine this C 11, so I will have to put I equals to 1, I will have to put k equals to 1. Now, here I can put I equals to 1 and k equals to 1 and j will vary from 1 to 2. Now, if j varies from 1 to 2, so very easily I will be getting C 11 is nothing but the maximum between the minimum between. So, I equals to 1 and let me put j equals to 1 here. So, 1 1, then comes your B j k. Now, j is equals to what? 1 and k is equal to 1. So, B 1 1 comma the minimum of A 1. Now, I will have to put j equals to 2. So, A 1 2, then comes your B j equals to 2. So, it is 2 1. So, first we will have to find out the minimum between these two, the minimum between these two, and then I will have to find out the maximum between these two. That will be nothing but is your C 11. Now, corresponding to this particular numerical example, like your A 11, that is your A matrix first row first column, and that is nothing but 0.2. Then comes your B 11. So, the B matrix first row first column is 0.3. Next comes your the minimum between A 1 2, that is your first row second column, and that is nothing but 0.3. Then comes your B 2 1, that is your second row first column, and that is nothing but 0.1. Now, if I compare 0.2 and 0.3, so the minimum will be 0.2. Similarly, if I compare 0.3 and 0.1, the minimum will be 0.1 and the maximum between 0.2 and 0.1 is nothing but is your 0.2. So, I can find out. So, this C11 is nothing but 0.2 and following the same procedure. So, I can also find out the other elements of this particular the matrix. For example, say C12 and let me try to derive this particular thing once again. Now, this C12 means what? C12 means your, if I just write down. So, Cik is nothing but Aij, then comes your Bjk. Now, the moment I am writing C12, so I equals to 1 and k is equals to 2 and once again j will vary from 1 to 2. So, this C12 is nothing but the maximum of the minimum between. So, I equals to 1, j equals to 1. So, A11, then comes your Bjk, j equals to 1 and what is k? K is nothing but is your 2. Minimum your next is what? Like your A12. So, I equals to 1 okay. And what about j? J is equals to your 2. So, A12 and next is your Bjk. So, j equals to 2 and what about your k? K is also 2. So, this is the relationship which we will be getting. Now, if you just put the elements, the numerical values like A11, first row, first column is 0.2, B12 that is your first row, second column 0.6, next your A12, A12 is 0.3 and B22 is 0.8. So, the minimum between 0.2 and 0.6 is nothing but 0.2. Similarly, the minimum between 0.3 and 0.8 is nothing but 0.3 and the maximum between them is 0.3. So, we can find out what should be the numerical value for this particular your C12. Now, by following the same procedure, so I can find out what is your C13 and C13 is nothing but the maximum of the minimum between A11, B13, comma the minimum between A12, comma B23 and if you just substitute the numerical values here. So, this will become the maximum between the minimum between 0.2 and 0.7 and the minimum between 0.3 and 0.6. So, here I will be getting 0.2, I will be getting 0.3 and the maximum between them is your the 0.3. So, C13 is nothing but is your 0.3. Now, following the same procedure, so I can also find out your C21 using this particular expression and if you insert the numerical values, I will be getting this and I can find out the maximum between 0.3 and 0.1 and you will be getting 0.3. Now, by following the same procedure, so you can also find out the next element that is your C22 which is nothing but this and we substitute the numerical values we will be getting like this, then maximum between 0.5 and 0.7 and I will be getting your the 0.7. Now, the next is your C23. So, I can find out what is this C23, this is nothing but this particular expression, substitute the numerical values, you will be getting this, find out the maximum between 0.5 and 0.6. So, you will be getting your C23 as 0.6, then we can write down the C matrix is nothing but. So, all the elements I can write down and it is nothing but actually 2 cross 3 matrix and these are the element C11, C12, C13, C21, C22, C23. So, you will be getting this particular the matrix. So, this is the way actually we can find out the composition of your the two fuzzy relations. Now, I am just going to start with another topic, that is your the properties of fuzzy sets. Now, if you remember, while discussing the concept of crisp set, we have already discussed about 10 properties. Now, these 10 properties if you look into, now this fuzzy set can follow the first 8 properties out of the 10, but the last 2 properties of the crisp set are not followed by the fuzzy sets, and those are nothing but the law of excluded middle and your the law of excluded middle, and then comes your law of contradiction. Now, if you see this law of contradiction, if you see the law of excluded middle first. Now, as I told that these two properties are not followed by the fuzzy set. One is law of excluded middle and your the law of contradiction. Now, according to the law of excluded middle in your the crisp fuzzy set, so this law of excluded middle is nothing but is your A union A bar, that is the intersection of two fuzzy sets like A and its complement, the union of two fuzzy sets, that is A and its complement, is nothing but the universal set. But in fuzzy sets you will find that your A union A bar is not equals to x. So, this particular violation we are getting in the fuzzy set. So, once again let me repeat, according to the law of excluded middle in crisp set. So, A union A bar is x, that is the universe of discourse, but in fuzzy sets A union A bar is not equals to your the universe of discourse. Now, let us try to explain. Now, supposing that, so this particular the triangle is going to represent the fuzzy set A x. Now, if this is A x, so we have already discussed now how to find out its complement. Supposing that this is denoted by, so this particular your the dotted line. So, its complement is denoted by this I have already discussed. Now, if you want to find out the union, so what you will have to do is, so you will have to concentrate here corresponding to this value of x, and according to your A x, so the mu is nothing but 0, but corresponding to A bar x, that is the complement. So, its your membership function value is your 1.0, and this is the union. So, we will have to consider the maximum, that means corresponding to this value of x. So, I will have to consider this as the mu. Next, the moment I am here, so this particular value of say x. So, now this is actually your mu corresponding to your the fuzzy set x, and this is nothing but the mu bar, mu corresponding to this particular A bar. So, this is nothing but mu corresponding to A, and this is nothing but mu corresponding to A bar. Now, these two mu's we will have to compare and we will have to consider the maximum. So, I am here. Now, if I follow this principle and if we increase the value of x, so there is a possibility that I will be getting actually this union, which is nothing but, so this type of thing I will be getting as the union of your fuzzy set A x and its complement. So, this is the thing actually we will be getting. Okay. So, this shaded portion is actually it indicates your union of a fuzzy set and its complement. But you see here I have got one white portion, here I have got one white portion which has not been attended. So, we cannot say that in fuzzy sets say A union A bar is equals to the whole thing, that is capital X. So, this particular condition holds good for the fuzzy set, but according to the crisp set this should be the condition. So, there is a violation of the fuzzy set, that violation is in terms of law of excluded middle. That means, your fuzzy set does not follow the law of excluded middle. The reason I am just going to tell you after some time, and let me explain this another law which is not followed by this particular fuzzy set, and that is known as law of contradiction. Now, according to this law of contradiction, in crisp set like your A intersection A bar is nothing but the null set, but in fuzzy set A intersection A bar is not equals to 0. So, there is a violation of this law of contradiction by fuzzy sets. Now, let us try to explain here. Now, supposing that, so this is nothing but the membership function distribution of a fuzzy set A x, and its complement is nothing but this dotted is nothing but its complement. So, this is your A bar x. Now, I try to find out their intersection. So, we will start from here. Now, corresponding to this value of x, say x 1, according to this A x. So, I have got the mu value which is equal to 0, and corresponding to this value of x 1, the mu value corresponding to this A bar x is nothing but 1, and we will have to consider the minimum. So, I will have to consider this particular the 0. The next is I consider another value of x, say x 2, and this indicates the mu corresponding to your A, that is nothing but mu corresponding to A, and mu corresponding to your A bar is nothing but mu corresponding to your A bar. Now, we compare mu A with your mu A bar, and this mu A is found to be minimum. So, corresponding to this x 2, so we consider up to this, and by following the same principle. So, if I just proceed with different values of x, so I will be getting actually one area, and this particular area is the intersection area. So, this type of intersection area I will be getting, and that is why your A intersection, your A bar is not equals to 0 in fuzzy set. Now, these two rules are not followed by your the fuzzy set. Now, I am just going to tell you the reason behind this particular fact. Now, let us try to understand what is the reason that these two rules are not followed by the fuzzy sets. Now, to understand that particular reason, let me assume that let me just draw it here, the same picture I am just going to draw. Now, supposing that I have got a fuzzy set for say the red color. Now, this is for the red color, and so this is nothing but mu equals to 0.0, 1.0 as we have discussed here. So, here so corresponding to your this thing. So, what I will be getting here is your this is nothing but is your complement. Now, if this is the complement, now if this is your the complement, then what we get is your so this type of so this is the complement, say it is not red. So, not red is actually the complement of the red. So, if the red is nothing but is your A x, so not red is nothing but is your A bar x. Okay. And here, so this is x. Now, supposing that I am considering a particular color, so that color is nothing but this, and I am just going to give a statement whether it is red or not red, or if it is red with what membership function value. Now, what we do is corresponding to this value of x or the color. So, what we do is we try to find out the mu. Now, this particular value of mu is nothing but that it is red with the membership function value say mu red, and it is the same color, it is not red with another membership function value, and this particular value is nothing but is your, so mu not red. So, this is nothing but is your mu not red. So, corresponding to this, so I will be getting this is nothing but mu not red, and here corresponding to the red color I will be getting your the mu red. Now, let us take a very hypothetical situation. Supposing that, so this mu red is nothing but 0.3. Now, what will happen to the value of your mu not red if it is a triangular distribution? So, this will become your 0.7. Now, let me give the statement. So, the same color is considered red with some membership function value, and it is also considered as not red with another membership function value. And let me put it in another way, that means an element that is the red color belongs to its fuzzy set as well as its complement with different values of membership. And this is actually the reason why this particular fuzzy set is not going to follow these two rules. So, let me repeat the reasons behind violation of these two rules by the fuzzy set is as follows. Here in fuzzy sets, an element belongs to a particular fuzzy set as well as its complement with different values of membership, and that is why we are getting this type of violation of the two rules. Now, I am just going to discuss, in fact, I am just going to define two terms. One is called the measure of fuzziness. So, how to mathematically find out the fuzziness of a fuzzy set? Now, to define this particular fuzziness of a fuzzy set, we use a particular term that is called the entropy. So, the term entropy is used just to define the fuzziness of a fuzzy set. Now, supposing that I have got a discrete fuzzy set, say A x, and I know element wise, so its membership function values, how to find out the entropy of this particular fuzzy set, which is denoted by capital H A. Now, this capital H A is nothing but minus 1 divided by n. Now, this small n indicates actually the number of elements multiplied by summation I equals to 1 to n mu A x I, then comes your log of mu A x I plus 1 minus mu A x I log of 1 minus mu A x I. So, using this particular your the expression, so I am just going to find out what should be the entropy of a fuzzy set, and that is nothing but the measure of fuzziness of a fuzzy set. Now, here I am just going to take one numerical example. Supposing that I have got a discrete fuzzy set A x like this, and its entropy, so according to the rule which I have already discussed, is nothing but minus 1 divided by n. Now, small n is equals to 4 here, because I have got 4 such elements x 1, x 2, up x 3 and x 4. Then comes your, so this particular mu, if you see this particular formula once again, so I can see your, so this is actually the formula mu A x I log of mu A x I, then 1 minus mu A x I log of 1 minus mu A x I. Now, if you see this particular formula, so I very easily I can find out corresponding to this x 1, I have got 0.1 log of 0.1, then comes your 1 minus 0.1 is 0.9 and log of 1 minus 0.1 is 0.9. So, I corresponding to this particular x 1, so I can find out your, so this part. Then corresponding to x 2, I can find out your this particular component. Corresponding to x 3, we have got this, and corresponding to x 4, we have got this. And now, if we calculate, so we will be getting actually one numerical value, and that is nothing but 0.2499, and that is entropy of this particular the fuzzy set, and that is nothing but the fuzziness of the fuzzy set in the numerical term. So, this is the way actually we can find out the fuzziness of a fuzzy set using the concept of entropy. Now, we are going to discuss like how to measure the inaccuracy of a fuzzy set. Now, supposing that I have got two fuzzy sets A x and B x defined in the same universe of discourse, and I want to find out the inaccuracy of fuzzy set with respect to fuzzy set A. So, I am just going to find out the inaccuracy of the fuzzy set B with respect to the fuzzy set A, and mathematically this can be expressed as follows, like this is equal to minus 1 by n summation I equals to n mu A x I log of mu B x I, then comes 1 minus mu A x I log of 1 minus mu B x I. So, this is the way actually we can find out your the inaccuracy of a fuzzy set with respect to your another the fuzzy set. Now, here if you see so I have got two fuzzy sets here. So, A x is nothing but this and B x is nothing but this. Now, inaccuracy of B x with respect to A x is determined as I A colon semicolon B is nothing but minus 1 by 4 0.1 log of 0.5, then comes your 1 minus 0.1 is 0.9 and 1 minus 0.5 is 0.5. This is actually corresponding to x 1. Similarly, corresponding to x 2 0.2 and log of 0.7, then comes your 1 minus 0.2 is 0.8 and 1 minus 0.7 is your 0.3. So, corresponding to x 2 we can find out this, then corresponding to x 3 we can find out this, and corresponding to your x 4. So, we will be able to calculate this, and ultimately if you calculate you will be getting 0.4717, and this is nothing but inaccuracy of fuzzy set B with respect to your the fuzzy set A. Now, this is the way actually we can calculate what should be the inaccuracy of a fuzzy set with respect to another fuzzy set. Now, the reference for this the discussion which I have already discussed your the textbook, you can see the soft computing fundamentals and applications written by me, published by Naroso Publishing House, and the reference book you can see fuzzy sets and fuzzy logic theory and applications written by George Clear and others, which is published in the year 1995. Now, just to summarize quickly, like till now we have discussed a few terms related to fuzzy sets. Some standard operations in fuzzy sets have been discussed in details, and after that the properties of fuzzy sets we have discussed, and we have already mentioned that out of the 10 properties of the crisp set, the first 8 properties are followed by the fuzzy sets, but the last 2 properties are not followed by the fuzzy sets. And at the end we have defined mathematically how to determine the fuzziness of a fuzzy set and inaccuracy of a fuzzy set with respect to another the fuzzy set. Thank you.